In our previous model, we studied the shape of distribution, and we said we have various shapes of a histogram. We have the skewed left, skewed right, normal, bimodal, uniform. All these are various shapes of a histogram. In this model, we will be looking more into the normal distribution. The normal distribution is symmetric. Another word for symmetric is bell-shaped. So looking at the shape that we have, it looks more like a bell. And it is also unimodal. So unimodal also implies there is only one peak. Alright. Also, another characteristic of the normal distribution is that the mean is centrally located. So which means that the mean is found at the center. The standard deviation is the best measure of variability in the normal distribution. In subsequent slides, we will see how the standard deviation is used to measure the variation. Also, the entire area under the curve represents 100%. This is also going to be useful in subsequent slides. Alright, now let's look at this normal distribution curve. As I said earlier, the mean is centrally located, so which means that the mean is found at the center. Moving to our right, one step, we have +1, +2, and +3. So +1 implies one standard deviation above the mean, and that is what we see here. So this symbol here is the standard deviation. So +2 means 2 standard deviations above the mean, and +3 also means 3 standard deviations above the mean. So this implies that the positive sign means above the mean. Alright, now let's look at values to the left of the mean. Over here, we have -1, -2, and -3. So -1 means 1 standard deviation below the mean. -2, 2 standard deviations below the mean. -3, that implies 3 standard deviations below the mean. So in this case, the negative sign implies below the mean. Okay, another thing that we'll look at from the normal distribution curve are the percentages. So 68% means we are 1 standard deviations within the mean, or 68% of the scores lie within 1 standard deviation. So in this case, as I said earlier, the mean is located at the midpoint. So within the mean means 1 standard deviation above and 1 standard deviation below. So the entire area over here is considered as 68%. Alright, then in terms of 95, we are 2 standard deviations above and 2 standard deviations below. So that gives us 95%. Then for 99.7%, we are 3 standard deviations within the mean, and that is 99.7%. As we saw in terms of the characteristics of the normal distribution, we said the entire area under the curve sum up to 100%. So in this case, we are left with 0.3%. So the 0.3% is divided by 2, and that gives us 0.15%, and that is the area at the extreme tails. So the area at the extreme tails forms 0.15% each. So now I want you to pause the video and sketch the normal model and label the mean and 3 standard deviations within the mean. Okay, so now let's look at some examples. This example is based on the example from the frequency table. We saw the example on the weight of babies. So in this case, we have our mean, which is mu, to be 7.05, and our standard deviation, which is sigma, to be 1.26. All right, so how did we get the values on the x-axis? As we said earlier, the mean is always found at the center. So now moving to our right, a step to our right is 1 standard deviation above the mean. So in this case, that gives us mu plus 1 sigma. So to find this value here, it's simply mean, which is 7.05, plus 1 times the standard deviation, which is 1.26, and that gives us 8.31. So that is seen over here, which is mu plus 1 sigma. So the next one is mu plus 2 sigma. So that gives us mu plus 2 sigma, which is 7.05 plus 2 times 1.26, and that gives us 9.57. Then the last one is 3 standard deviations above the mean, which is mu plus 3 sigma, and that is what we see here as mu plus 3 sigma, which is 7.05 plus 3 times 1.26, and that gives us 10.83. Alright, so now moving to our left, we said a step to our left from the mean is 1 standard deviation below the mean. So in this case, in terms of adding, we are subtracting. Alright, so we have 7.05 minus 1 times 1.26, and that gives us 5.79. We have 7.05 minus 2 times 1.26. That gives us 4.53. So that is 2 standard deviations below the mean. And lastly, 3 standard deviations below the mean. So that is 7.05 minus 3 times 1.26. That gives us 3.27. So that is how we get these values. Alright, so now in order for us to interpret what 68, 95, and 99% means, in this case, 68 implies that we are 1 standard deviations within the mean. So in this case, 68% of the baby's weight fall within 5.79 and 8.31, and that represents our 68%. So it's giving us the range of values that covers 68%. Alright, now the next one is 95, and we know that 95 is 2 standard deviations within the mean. Oh, sorry. So we have 95%. And lastly, we have 99.7%. So in this case, we can say that 99.7% of the weight fall between 3.27 and 10.83. Alright, now let's look at these various normal curves. In this case, the normal distribution is the mean is centrally located. So for the first graph, we can see that the midpoint or the central points are different from the 2 curves. So which means that the mean values are different. Looking at their shapes, they both look alike. So So that represents the same standard deviations. For the second curve, their midpoint values are the same. So then this implies the same mean. However, their shapes are different for the second curves. So then that implies different standard deviations. Now for the third, both central points are different and they have different shapes. So then they have different means and different standard deviations. Another interesting thing about the normal distribution is that it helps us to compare data values with different means and standard deviations. This is a simple illustration about you and your roommate, where you are in the stats class. In your homework 1, you had a grade of 93, and based on your class, the mean was 90 and the standard deviation was 9. Then your roommate, who is in the drawing class, had a grade of 7 in his homework drawing, and the mean in his class is 5 and the standard deviations is 1. So in this case, we want to identify who did better than the other. Over here, we cannot simply make our judgment using their raw values. We cannot do that because the means and standard deviations are different from both classes. In order for us to judge or to know who did better, we need to calculate the z-scores. So these z-scores helps us to standardize our values for comparison. So in this case, to calculate the z-score, we use this formula, and I highly recommend that you know this formula for your test. Alright, so over here, x represents the raw value, mu is the mean, and sigma is the standard deviation. Okay, so let's see how we can work with that. Okay, before we calculate the z-score values, let's look at what the z-score means. The z-score helps to measure the number of standard deviations a particular value is from the mean. So an example is, if I have a z-score value of 2, it means I am 2 standard deviations above the mean. And if I have a z-score value of minus 1.3, it means I am 1.3 standard deviations below the mean. Let's take note of something interesting here. In this case, a positive z-score value implies above, and a negative z-score values implies below. This will be very helpful in our examples. Another thing we would like to discuss here is the standard normal. As I said earlier, the mean is centrally located in the normal distribution. So in this case, we represent this to be our mean, which means that the mean is 0. So what is our standard deviation? We have 1, 2, and 3 that is moving to our right. So in this case, the standard deviation is 1. So we give a special name to a normal distribution with a mean of 0 and a standard deviation of 1, and that is called the standard normal curve. Alright, back to our example. In order for us to determine who did better, as I said earlier, we need to calculate the z-scores because the means and standard deviations are different from both classes. So in this case, using our formula, we said the z-score value is given as x minus mu divided by the standard deviation. So x represents the raw value. So the first one, the raw value is 93. So we have 93 minus 90 divided by 9. That is for the person in the stats class. Then in the art class, we have our z-score to be 7 minus 5 divided by 1. So that gives us 0.33 and 0.2. So in this case, your friend did better than you because your friend has a higher z-score value. Now, visualizing it, we have our z-score values as calculated from the previous slide. In this case, this is the exact location of the z-score values. So then, over here we have 0.33 and we have 0.2. So you realize that and we have 2. So you realize that 2 is far to our right than 0.33. So then your roommate did better because the drawing hazard was higher above the mean than the statistics. So looking at where our mean value is, a z-score value of 2 is much higher above the mean than a z-score value of 0.33. Okay, now let's look at another example. In this example, exam 1 had a mean of 85 and a standard deviation of 14. We want to calculate a z-score value of 88. So likewise, we have our raw value minus our mean divided by our standard deviation. So using this formula, we get a z-score value of 0.21. So then what does this mean? This means that the raw value of 88 is 0.21 standard deviations above the mean. Alright, this ends for this lecture. Let me know if you have any questions.